Hi, let's talk about what happens when fluids get set in motion. And there are two primary pieces to the picture. The first is what we call the idea of continuity. And continuity is essentially the idea of conservation of mass, or really, conservation of the flow of mass. So if you were to take a look at a system of moving fluids, if you were to draw an imaginary line in a closed system, something where no fluid escapes, no fluid gets added, then the amount of mass per second passing through each one of those lines has to be constant. Otherwise, you're either magically adding stuff or magically removing stuff. And physics isn't the wizarding world of a famous magician. So, what we're going to do is take a look in the context of a river, but this applies to all fluids. So if you want to figure out the amount of mass per second that's moving at any given point, the mass per second would be equal to the density of that fluid times what we call the volume velocity, the amount of volume per second that moves past that point. And the volume velocity is going to be equal to the cross-sectional area that fluid is occupying times the speed of the current of that fluid, how fast the fluid itself is moving. So if I look at 2 points, point 1 and point 2, the density at point 1 times the cross-section at point 1 times the speed of the fluid at point 1 is constant. So it would be the density at point 2 times the cross-section at point 2 times the velocity of the current at point 2. Now, typically, we talk about incompressible fluids at the introductory level. And an incompressible fluid is a fluid where the density won't change. So if the density is constant, and for liquids, that's the assumption we're making, then it's just the volume velocity that's conserved. The cross-section times the current is going to be constant at all points. Now, say for the example of this river, it starts with a current of 1.2 meters per second when the river is 360 meters across and 8 meters deep. So we could figure out the cross-sectional area, multiply that by our current, and that would give us how many cubic meters per second are flowing through that river. Now when a river narrows, in the English language, we like to use the word narrows and rapids interchangeably, because at the narrow point of rivers, we observe it to be a rapid current. And that's just continuity at work. So, say the river narrows to 40 meters. Well, the current in section 2 would be equal to the cross-section in section 1 times the current in section 1 divided by the cross-section in section 2. Well, the cross-section is the width times the depth. Since the depth is the same, that means the current in section 2 is going to be the current in section 1 times the ratio of the widths. The width in section 1 divided by the width in section 2. I go from 360 meters to 40 meters. That's a factor of 9 times less cross-section, which means I have 9 times more velocity. 9 times 1.2 meters per second gives me 10.8 meters per second. So to 2 significant digits, we could round that to 11 meters per second. Thanks for watching.